I have a task in hand. Because I had a task in hand, I decided I should not usually wear what I'm used to wearing, which is a shirt and a tie. I decided not to use any presentation, which I'm quite used to, that I'll have set of slides and I'll always present. And third, and the most important part, is that I'm going to behave like a watchman today. Let me tell you the story of a watchman. Since they said that I've been in the industry for long, an adjoining industry, which is automotive industry, they're usually a set of people whom people look upon every time they need to bring state-of-the-art vehicle. So there was this big manufacturing of a car that was taking place. It was slated to be the best car that ever would come out from that stable, and the car actually lives up to its promise. This is done by a designer. Everybody likes it so much that the CEO comes and applauds him. And in that excitement, they realize that now it's time to take the car outside the manufacturing area to the showroom. And at that moment, it's found out that the car that was designed is actually 2 inches taller than the exit door. Obviously, with all the excitement comes all the chaos that what are people going to really do? How will they take out the car? So designer is pretty clear. He says, hey, it's pretty simple. Just break the door and we'll take the car out. You repair the door later on. The painter was standing there and he says, hey, it doesn't matter. You don't need to break the door. Just scrape the car through. There'll be some dents. Paints will go off. But we can always redo the car. The CEO is not excited because for him, he feels that how can a brand new design, a marvelously done car, go through scratches and hurting the building and stuff like that. And he's just not enjoying this conversation. Till a watchman who's been listening to all this chaos decides to walk into the room. The watchman basically says that if you don't mind, can I give you an advice? And everybody wonders, what can a watchman give an advice? So he looks at the people and says that you are talking about a car which is 2 inches taller than the exit door. Why don't we deflate the tires? The car reduces its height, move the car out, put the air in, no door broken, no painting to be done, and we'll have a great start. Obviously, this one is met with all the applause, and people wonder, how can a watchman know so much when the most technical people couldn't figure out? So the third thing that I did today is that I said, I'm not going to talk to you anything about technology the way technical people talk. Let's talk like a watchman. So no suit and boot, no presentation, and purely talking to you like a watchman. But my topic of conversation today is that since 1955, mankind has always been hoping, how do we make our machines intelligent, and why there's so much of conversation today. But if you really want to understand that aspect, let's look through 2 ways of looking at our lives. All of you probably are going to disagree to a greater extent, but I'm going to pose this question right in front of you. If you look at the world, our world is made of 2 things. One is God-made, called natural, and the other is man-made, called artificial. The humans have this tendency to make man-made things look like God-made things and make God-made things look like man-made things. Will you agree? You all agree? Fantastic. And this has been our trias right from the mankind has evolved. Look at 18th century, a century which was all about agricultural revolution. What did we drive the agriculture revolution on? Muscle power, animal power, right? So what we did is that every time we had to bring water from a well, we would put a hand pump, lever it, and the water will come with least amount of effort, right? We would take horses, put them on a carriage, and we could now transport ourselves into many, many miles. Then came the invention of power. What we did was that we took power and we added it to things. We added it to the pump. It became electrical pump. We took horses and converted that into a switch. Every time you put on the switch, 250 horses at your disposal can take you through the highways, and you could now run through a ring road, you can make these lovely buildings, you could construct cities, you could do so much of business, and that's what was called the Industrial Revolution. It was a idea about electricity getting added to man-made things, and it became an industrial revolution. Having said that, if I was to tell you now add smartness to them, it'll become artificial intelligence. Imagine the same electrical pump will become a smart pump. The same car, which had 250 horses, now accompanied by 250 minds, will become a smart car, right? That's the power of that idea into 10x, and that's the idea that's going to scale you millions and millions of levels up and going to create the next wave of the revolution. Now, there are many controversies. I like to call it the second revolution, but people may call it the fourth revolution, depending upon how you look at the phases. But your idea with artificial intelligence stands to prosper more than what we have seen so far. So I'm given to understand many of you have these great ideas. If you're applying AI to it, you are just the right set of people who's going to really relish what mankind is going to do. But having said that, I've walked through many corridors. I walked through the corridors of the government, I walked through the corridors of corporate, I meet a lot of universities, and I hear three words: AI, machine learning, and deep learning. By the time they talk about AI and machine learning, the deep learning part is actually not spoken too much. And if you try and find out from people what is really the distinction between three of them, I think they can pretty much articulate the intent behind AI, but they pretty much get confused with this whole definition that revolves around machine learning and deep learning. So if I look at the purest definition that I like to see, which was made by Alan Turing, he stated that any machine or a computer, if can show the intelligence that can deceive a human, should be called artificial intelligence system, right? So we should be able to deceive a human, which is very difficult for machines to do. Why is that? It's predominantly, if you look at ourselves, we are built on two definitions, two concepts. A concept of understanding, a concept of reasoning. The concept of understanding is nothing but your subconscious intuition. Nobody tells you how to basically make your morning breakfast. You just make the breakfast, you think something, and you move on, and you just get on to the next task. The other part is the reasoning part. The reasoning part is very logical, it's model-based, it always happens through what we've learned previously and happens one at a time. It's really good because it's extremely effective, predominantly because there's a reasoning behind it. You can logically find out, especially when you are very confused. But both those concepts really help you out. How do you really build thinking and therefore what goes into artificial intelligence? So you're saying I have 5 minutes? I thought we had 20 minutes. Okay, so we're going to hurry this up. So if you get this predominant concept that as people who have been dealing with machines, we predominantly have dealt them through the reasoning aspect of it. Let's take a simple example. If there was an airlines and you were a programmer, they asked you to come and understand what goes into the airline's part. You will come understand what's required. You will delete whatever is not required in your information, and you'll start programming it. You'll make a reason of it, and a program will get built. And when they find out that there are few things you didn't understand, they'll call it a bug. You'll write another software code, and that's how the programming will be done. This is really good for airline programming, but if somebody tells me, hey, I want to recognize Vishal amongst the crowd, how am I going to know that there was Vishal who came into Taj Yashwantpur for Tech Sparks, and he entered at so-and-so time, this is what he was wearing. How am I going to do? It's going to be really tough for computers to do it. So anything that is not explicit is very difficult, and that's where the scientists at Toronto University in 2012 used neural networks to create deep learning that helped people to start doing many things around image, speech, text, and video. It helped us to find out what exactly happens there. It was not dependent upon programmers anymore. It was dependent upon the training that you will provide through the data, and the data will tell you what are the features inside. So this whole concept called deep learning has spurred the new revolution of artificial intelligence. It's fundamentally very different. So the part that I want to leave you behind with, it's not something where you guys have been taught to think like reasons. It's about your intuition, it's about your effectiveness, it's about model free, it's about the impact that is going to make onto it, and we need to understand how do we go about it. Let's talk about quickly about some examples that are happening. I'll use first one from healthcare, which is just going through a complete shift in its approach. You know, the healthcare industry is over $1 trillion. They spend 20% of their money on research and development. They want to go beyond the pills. They want to make sure that the trauma that you go through can be reduced. And that's where the medicine is going to really meet its objective. There's an approach which US government has taken over with research labs. And what they have created is a fight against cancer. The fight against cancer is about how can we find discoveries of cancer that can accelerate solutions which would have taken 20 years to come back in 5 years' time. The way it's working out is that people are trying to understand through deep learning what goes inside the DNA, RNA of all the cancers that have evolved. It's trying to figure out through molecular simulation what kind of protein buildup really takes place. And thirdly, it's trying to assimilate all the journals and all the work that has been done together so that the combination of all these three things helps you to mitigate cancer to the extent that you can do. It's really at the leading edge part. I'll use one more example, which is something that we use. There's some lovely ladies around here. You all go and you buy creams for your skin. The whole idea is that if you apply the cream correctly, you look younger and your skin can meet its objectives. But the world's largest FMCG company, Procter & Gamble's issue is that people buy cream, but they can't retain customers. And they figured out that if they apply deep learning, and if you took a selfie and you took your face and you posted it back, it could actually recommend to you the cream. The cream not only for the age of your skin, but every spot on your skin, how old it is, or what really are the blemishes, what are the dark points, and recommend to you. It's oil of Olay. If you go and look at on the net, you'll find that there is this case study, and they found that in an industry where it's extremely difficult even to keep 25% people regular with them, they reach attraction levels of 94. So 94% of the people who went through those sites were retained with them because now it was precision. Your skin was actually reacting based on the dermatologist study. We can go about this for a long period of time. I have him who's holding me up, but 3 points. Deep learning is transforming AI. It has an immense impact on our lives. It's extremely important that young India understands what deep learning is. It's not code-based. We need to basically figure out how we're going to take advantage of this. And third, but not the last, that, hey, let's go and embrace it because it's going to make a difference to all our lives.